Hi guys, I'm Lakit. Today my technical seminar topic is unleashing the potential of IoT in tackling the ocean pollution, a data-driven approach for marine ecosystem conservation. As we discuss the topic name of the technical seminar is unleashing the potential of IoT in tackling ocean and pollution. We'll, under the guidance of Amrita C. Ma'am, Assistant Professor and Department of ISC, and from the ISC department. So we'll go to the contents. There will be introduction of the topic of the seminar, and the next is related background. I have been done and research of so many other papers about the different topics that is included in my technical seminar topic to gain the knowledge from the previous insights. The next is the implementation that have been done and that could be possible if it's funded to complete the total project. Results and discussion, what might be the result and what are the out- outcomes that can be achieved after the completion of the project, and the conclusion, and what are the papers I have referenced previously. We discussed the related background. We'll be having all the names of authors who have been wrote those papers and published those to gain the knowledge. Let's dive into the introduction part. The topic ocean pollution is pressing global environmental challenge that threatens marine ecosystem and human well-being. The rise of Internet of Things offers unprecedented opportunities to address this issue through data-driven approaches. By leveraging IoT devices such as sensors, drones, and underwater vehicles, we can collect real-time data on ocean parameters and pollutants. This data-driven approach enables us to gain insights into pollution sources, trends, and impacts on our marine ecosystem. In this paper, we explore the potential of IoT in marine ecosystem conservation, focusing on its applications in monitoring, analysis, and management of ocean pollution. We highlight the benefits of data-driven approach and propose strategies to harness IoT technologies for effective conservation efforts. The research I have been done to complete this project is Internet of Things based aquaculture and an overview of IoT application on water quality monitoring. This is one of the paper I have been researched. In this, they mention the aquaculture industry. The Internet of Things is the essential component of creating intelligent systems for monitoring water quality. From this paper, I have learned the most of the most of the contents that have been achieved in our project because it is based upon the water quality, and our main aim is to maintain the quality and noting whether the quality is normal or not normal. So it will be very helpful to our project. So I have been chosen it in the first preference. In this paper, they mention that it can be easily identify the temperature, pH level, and amount of dissolved oxygen fertilizer concentration by using the IoT with the help of sensors to keep track of conditions. These technologies improve the effectiveness and output of the aquaculture operations and guarantee that aquatic life can thrive in ideal environmental circumstances. The next paper I have researched is development of an IoT-based indoor air quality monitoring platform. Monitoring the air quality within a building is another area that has reaped considerable benefits from the Internet of Things. Monitoring solutions for indoor air quality based on the Internet of Things use sensors to detect contaminant and offer information on air quality in real time. These devices are necessary for spotting possible health risks and sustaining healthy conditions within buildings. And the next paper is fog-based marine environmental information monitoring toward ocean of things. It is also very important information that could be helpful for our project. Monitoring the state of marine environment is one such an area of interest of this paper. IoT system monitor various ocean characteristics like water temperature, pH, dissolved oxygen, salinity, turbidity, oil spills, and microplastic pollution. Comparing with the first paper, this paper they also included the turbidity sensors and oil spill detection by using the various substances by mixing and easily identify which is whether the place is oil spill or not. And it's there a very important part called microplastic pollution. It could also be identified by using the sensors. These intelligent marine monitoring devices collect real-time data, enabling early identification of pollution occurrences and facilitating quick responses and conservation initiatives. These all papers made us to do work fast rather than researching from the initial stages on that particular topic because they already done this and implemented in the real time, so that we can reference and improvise it in our project or just inspire from them. And another is secure communication in IoT enabled embedded system for military application using encryption. As we are discussing about uh, communication between the sensors and Wi-Fi module and sensor module, it is very difficult to communicate because the sensors will be in the underwater, and to make it possible and very faster and secure way, we should be using the algorithms like DES and advanced encryption standard algorithm. They are actually used in military applications. We are using it because due to the faster communication and secure communication. Why it is secure means it's a lot of data, and some of them can easily cheat on it and provide wrong data in the social media platform, so it can be difficult to identify which is correct or wrong information. So making it secure will be a good idea, so we'll be focusing on secure communication also with this with the help of this paper. And second one is wireless optical communication based cooperative IoT and IoUT system for ocean monitoring application. There are two types here, IoT and IoUT. Internet of underwater things. It's very important to know because our sensors mainly will be in the underwater. We don't know how it can react due to that conditions and environmental posture. So by knowing this information, it would be helpful for to us maintain in the reliability. Even if it is in the very difficult situation, we can easily work on it. They mention in the context of ocean water quality and pollution monitoring, this approach can enhance the connectivity and data transfer capabilities of sensors deployed underwater. As we discussed about the previous paper, this also make the transfer of data faster. So it is major contribution for our project. It enables real-time data collection, transmission, and analysis, facilitating timely decision making regarding environmental monitoring, pollution detection, and resource management in marine ecosystems. Overall, the use of wireless optical communication-based cooperative IoT and IoT systems can contribute to more effective and comprehensive ocean monitoring applications. If you go to the working or implementation part of a project, to, co- to combat ocean pollution and IoT may gather, process, and analyze real-time environmental data by the seamless integration of smart devices, sensors, and data analytics. IoT relies on strategically placed sensors and devices in the ocean to monitor water quality, temperature, salinity, dissolved oxygen, nutrients, and pollutants via bios and drones, satellites, or remote stations, providing continuous environmental data. IoT flawless connectivity and data transfer are ensured via protocols like MQTT message queuing, telemetry transport, enabling sensor data to reach centralized cloud platforms in maritime environments efficient. Cloud-based systems process raw data using edge computing for early analysis and filtering, generating insights on ocean pollution through data analytics and machine learning. If we look up both the model of the system, there will be five components like co-sensor, node, central hub, communication interface, cloud server, remote management. These all will be working rigorously to achieve the aim of the project. We'll be mainly focusing on four approaches: productive modeling, collaborative approach, IoT's role in ocean awareness, IoT's role in marine ecosystem. If we talk about the productive modeling, IoT enables data-driven anticipation of pollution level changes, aiding in pinpointing polluted areas and guiding timely policy making to prevent severe pollution issues. In our project, basically, they will be identifying very large prone polluted areas of underwater, and they will be informing the other NGOs and government of that particular ocean properties, so that in the near future there won't be any repeated pollution in that area. So it will be very helpful for improving the sea environment. Collaborative approach. Collaboration among public agencies, academics, NGOs, businesses, and individuals is vital for effective IoT strategies, fostering multidisciplinary awareness and innovative solutions against marine pollution. As we discussed in the productive modeling, we'll be collaborating with some NGOs and government who are really willing to work with us. So we'll give information for them, and they will help us in the preventing the pollution and removing the sediments from the ocean at the places where it is polluted, so that we can also have some more innovative solutions, and there will be communication between us and them, and it will be a win and win situation. IoT's role in ocean awareness. Open access to IoT data fosters public awareness of ocean impact, promoting responsible actions and a collective sense of duty for ocean conservation. As we all collect the data from the ocean, and we'll get to know what is a major issue of this pollution, and it will only point to the human race. So we'll be publishing the all the data uh, after the conclusion we got to the public, so that they will get to know we are the reasons that these water bodies are getting polluted, and they will get awareness. So what we should do to not to make it repeat again. So it will be a good thing. And IoT's role in marine ecosystem, leveraging IoT sensor deployment, real-time monitoring, and predictive modeling empowers targeted interventions, promoting ocean health and biodiversity conservation through data-driven decisions and public awareness. The materials we used in our implementation process is NodeMCU with ESP8266. It is Wi-Fi connecting in a single package. It also have the Bluetooth connection model, but we only use Wi-Fi. It will be a efficient thing. Deployment of IoT projects for both purpose and enthusiasts. NodeMCU processor and memory with its 32-bit NCL processor capable of 160 megahertz, and 4 MB of flash memory and 80 KB of RAM offering ample space. It's a sample of properties, and it could be improved up to some petabytes and terabytes of memory and RAM. Temperature sensors, water temperature sensor track the cyclical changes that significantly impact marine ecosystems and the distribution of life. And there are also nutrient sensor which will be calculated all the potassium, nitrogen levels in the water, and the pH level of the water, whether it is acidic or basic or neutral position, or correct to the water quality level. So it will be noted all those things. And again, there are turbidity sensors and oil spill detectors. These are all the sensors that will be used in the working or implementation process. We talk about the results and discussion. Data-driven marine conservation with IoT. It will help the new people to come and join with us, like any startup that are basically providing the analytical part to the sensor data or any type of data. We'll be collaborating with them, and they will be sending the sensor data. They will be giving the visualized methods and will be used to represent to the public, and we also get to know whether it is resolving or not. So it's a very good collaboration. Efficiency of IoT sensors in ocean pollution monitoring. IoT equipped sensors have demonstrated their effectiveness in real-time pollution monitoring. This real-time data allows scientists and government entities to respond promptly to pollution incidents, preventing severe harm to marine ecosystem and coastal areas, particularly through early identification of oil spills and other contaminants. And the major result is pinpointing pollution origins and monitoring effect. We'll be identifying whether where it is morely affected in the ocean. If you see the table image, the figure explains that census data for ocean pollution conservation. Sensor type, measured parameters, sample values. These are all the sensors that will be working. Water quality sensor, turbidity sensor, dissolved oxygen detection, pH sensors, microplastic sensors, nutrient sensor, weather sensors. So go to the conclusion. IoT technology is a game-changing strategy for ocean pollution monitoring and marine ecosystem preservation. Real-time data gathering via various sensors provided valuable insights into water quality, pollution sources, and marine life behavior. Data-driven strategies facilitate early detection of pollution incidents, improving response measures, and reducing ecological harm. IoT applications enhance public awareness, prompting collective responsibility and behavior changes to protect marine environments. Challenges like data privacy and cost are addressed through collaborative efforts and multinational initiatives. These efforts aim to maintain the delicate balance of marine ecosystem for the benefit of future generations. These are all the references I have made and learned from those papers, and thank you.